Welcome all to my video lectures on application of partial differential equation in engineering mathematics. This is the fourth lecture on application of partial differential equation. Today we see one application, that is one-dimensional heat flow. In this application we should have to consider a uniform beam of cross section which is covered with the material which not allowing the heat to pass out of the bar, but the heat flow in the direction of x-axis and perpendicular to the cross section. Suppose small u is a temperature of the bar at any point at any time t. As the temperature u of the bar at any time at any point with the distance x from one end of the bar, then the theory of partial differential equation can be applied on that bar. In this we should have one end of the bar as a origin and the direction of the heat flow as positive x-axis. Then we get the one-dimensional heat flow equation, that is dou u by dou t is equal to c square dou 2u by dou x square. In this equation we get c square is beta upon s rho, where beta is the thermal conductivity and s is the specific heat and rho is nothing but the density. So that we get the one-dimensional heat flow equation. So as u decreases with the increases in the time t, therefore the solution of this equation is u is equal to, in first bracket, c1 cos nx plus c2 sin nx, bracket close, and into multiplication with the second bracket c3 e raised to minus n square c square t, bracket close, is nothing but the required solution of heat equation. The uniform bar is displayed on xy plane and the heat flow along the x-axis as shown in the figure. So let us see the example on one-dimensional heat flow. The example is solve dou 2u by dou t is equal to 4 dou 2u by dou x square, subject to the conditions u of 0 t is equal to 0. This is first condition. Second condition, u of pi t is equal to 0, comma third condition, u of x0 is equal to 2 sin 3x minus 4 sin 5x. So this is the given example with the one-dimensional heat flow equation. So remember the one-dimensional heat flow equation, that is dou u by dou t is equal to c square dou 2u by dou x square. So let the given equation, that is dou u by dou t is equal to 4 dou 2u by dou x square, write it as equation number 1. Then compare this equation to the standard form. We get c square is equal to 4, therefore c is nothing but 2. Then as we know the standard form of the solution of one-dimensional heat flow equation, that is u, and it is given u is a function of xt is equal to c1 cos nx plus c2 sin nx in first bracket into, in second bracket, c3 e raised to n square 4t. Write this as equation number 2. Then putting the condition, so the first condition we have given u of 0t is equal to 0. As the condition x is equal to 0, we have the value of u will be 0. So put this value in equation number 2, that is in the solution of the heat equation. So we get 0 is equal to, so x is equal to 0, so cos 0 is 1, so it is only c1 is remaining in first bracket, sin 0 will be 0, into, in second bracket, c3 e raised to minus n square 4t. So this term as it is because there is no x term. Then put this then comparing to this equation, so we get c1 will be 0, So putting the value of C1 again in equation number 2, we get U is equal to C2 sin nx into C3 e raised to n square 4t. So this write it as a equation number 3. So again in equation number 3 you also write C2 into C3, the multiplication of two constant become another constant you should have to write here. So U is equal to sin nx in bracket C2 into C3 is equal to e raised to minus n square 4t. This is equation number 3. Then using the second condition, and the second condition is U of pi t will be 0. It means at x is equal to pi, your value of U of xt will be 0. So put this in equation number 3, then we get U will be 0, that is U of xt will be 0. So 0 is equal to, in first bracket, C2 sin n pi, because the value of x is pi, bracket close. In second bracket, C3 e raised to minus n square 4t, that is C2 into C3 we have to write. Then 0 is equal to sin n pi C2 into C3 e raised to minus n square 4t. So in both the term, which term will be 0? So here sin n pi will be 0. So we know that sin n pi will be 0. So as we have sin m pi will be 0. So comparing to both the term, we get n pi is equal to m pi. So n is equal to m, that is the value of m becomes 1, 2, 3 and so on. So n is equal to m. So put this value in equation number 3. We get U is equal to sin mx into C2 into C3 can be written as a single constant, that is A, capital A, into e raised to n is nothing but m, so it is minus m square 4t, that is U is equal to A sin mx into e raised to minus m square 4t. Write it as equation number 4, where m is nothing but the value 1, 2, 3, that is so on. Then therefore for m is equal to 1, 2, 3, we should have to combine all the solutions. Hence U of xt is equal to summation of m is equal to 1 to infinity am sin mx into e raised to minus m square 4t. So this is equation number 5 after using the second condition. Then let us take the third condition. In the third condition we have U of x0 is equal to 2 sin 3x minus 4 sin 5x. It means that at t will be 0, the value of U of x0 will be 2 sin 3x minus 4 sin 5x. So put this value in equation number 5. So we get 2 sin 3x minus 4 sin 5x is equal to summation m is equal to 1 to infinity am sin mx into e raised to minus m square 4t. So expanding this summation for putting the value m is equal to 1, 2, 3 and so on. So we get 2 sin 3x minus 4 sin 5x is equal to, for m is equal to 1, so we get a1 sin 1x plus a2 sin 2x for m is equal to 2 and so on, a3 sin 3x plus a4 sin 4x plus a5 sin 5x plus dash 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 for the subsequent value of m. Then comparing to the left hand side and right hand side, we get 2 sin 3x is equal to a3 sin 3x and minus 4 sin 5x is equal to a5 sin 5x. So these two equations we get. So comparing these two equations, we get a3 is equal to 2 for m is equal to 3 and a5 is equal to minus 4 for m is equal to 5. So putting the value of a3 and a5 for m is equal to 3 and m is equal to 5 in equation number 5, we get U of xt is equal to summation. So not necessary to take the summation, we should have the values. So it is equal to 2 sine 3x e raised to minus 36t minus 4 sine 5x into e raised to minus 100t. So this is nothing but the required solution. So the next example, that is solve the boundary value theorem. Dou u by dou t minus dou 2u by dou x square will be 0 for x in between 0 to L, subject to the condition u of 0t is equal to u of Lt is equal to 0 and u of x0 is equal to 3 sine m pi x. So in the condition u of 0t and u of Lt both are same, and that is nothing but the 0. So this is the combined condition we have given. So let us see the solution. Let the given equation write in the way of one dimensional heat flow, that is dou u by dou t is equal to dou 2u by dou x square. So comparing with the standard form, we get a square is equal to 1. Then consider the solution. We know that the solution of one dimensional heat flow equation, that is u of xt is equal to c1 cos nx plus c2 sin nx in first bracket, and in second bracket c3 into e raised to minus n square a square t. So write it as equation number 2. So the first condition, that is u of xt will be 0 at x will be 0. So put this value in equation number 3. We get 0 is equal to c1 as x will be 0, sin 0 0, cos 0 is 1. So it remaining c1 in first bracket, in second bracket c3 e raised to minus n square at. So in this c1 will be 0. So put this value in equation number 3 again. We get u of xt is equal to c2 sin nx into c3 e raised to n square a square t. That write it as the equation number 4. Similar to the second condition, when u of Lt will be 0, it means that x is nothing but L. So u of Lt will be 0. So put this value in equation number 4. We get 0 is equal to sin nl, c2 into c3 becomes a in second bracket into e raised to minus n square a square t. Then here sin nl will be 0 and we get sin m pi. We know that sin m pi will be 0. So comparing to both these, nl is equal to m pi, where m is nothing but 1 2 3. So nl is equal to m pi. Hence we get n is equal to m pi by L, as m is 1 2 3 and so on. Put this value in equation number 4. So we get u of xt is equal to sin m pi x by L into a into e raised to minus n square a square t. So sin m pi x by L a into e raised to, so the value of n is nothing but m pi by L, so minus m square pi square by L square into t, as a square will be 1. Therefore we get u of xt is equal to a sin m pi x by L into e raised to minus m square pi square t by L square. That is nothing but the equation number 6. Then using the third condition, as t will be 0, u of xt will be 3 sin m pi x. Put this value in equation number 6. We get 3 sin m pi x is equal to, so for the value, respective values of m, it is nothing but the summation m is equal to 1 to infinity a0 sin m pi x by L. So for the subsequent values of m, we have m is equal to 1 to infinity. So 3 sin m pi x is equal to a0 is the constant term taken outside, and into summation m is equal to 1 to infinity sin m pi x by L. So comparing these two equations, we get a0 is 3 and m is equal to, small m is equal to m by L, that is small m have value. So put this value in equation number 6. We get u of xt is equal to summation 1 to infinity a0 sin m pi x by L into e raised to minus m square pi square L square into t. So this is the required solution of the given equation. Thank you.